Good morning, student. I hope you have learned part 1 of the sound chapter. We have completed all the theory part as well as exercises. I hope you all have completed in your register. You have understood also? In case you have any difficulty, you can ask me between 5 to 6 p.m. Now, I am going to take B part of sound chapter. See, before going to discuss this, one thing I would like to tell you, like everybody, they all keep vibrating. They have their own natural frequency. So here, I am going to discuss types of vibrations one by one. And the first type of vibration is natural vibrations. If we just, I'm giving you an example. If we just hold a bob in a thread and we slightly disturb, set into the vibrations. What is your observation? What is your observation? Have you ever experienced? You can take example of for example, if you tie one stone in a thread and just you hang and slightly disturb and just check it out. What will happen? What will be your observation? You will notice that after some time it will stop vibrating. It come into its rest position. Have you ever thought why? Because due to the presence of medium, there is some resistive force. So you all know what is resistive force or frictional force? They opposes the motion. They opposes the motion. It means the motion of the pendulum or stone will decrease slowly and gradually, and it comes into rest position. Why? Due to presence of the medium. Some external forces apply, resistive forces applied. But what is natural vibration or free vibrations? Here, see, what is free vibration? The periodic vibrations of a body in absence of any external force on it are called the natural or free vibrations. What do you mean by this? It means if we set a body into vibration and no external force act on it, so body will continue in vibration. But only when it is possible, when there is no resistive force. So these kind of vibrations takes place in vacuum where no medium is present. So no frictional force act on it. The natural vibration of a body, got me? Again I am repeating what is the definition. The periodic vibrations of a body in the absence of any external force on it are called the natural vibration or free vibrations. The natural vibration of a body depends on shape and size of the body. The time period, this question is asked, what is the factor on which natural vibration depends? So what is answer? Shape and size of the body. The time period of the body is called natural period, and the frequency of freely vibrating body is called natural frequency. The natural vibration of a body, as I told you earlier, the natural vibration of a body occur only in vacuum. Again I am repeating, this is one of the most important question for the one word. It is asked, what is condition where the natural vibration takes place? When the natural vibration execute. So what is the need? It takes place only in vacuum. In absence of frictional force. It means there is no external force act on the body. Now, these are the points which you need always. The amplitude and frequency of a natural vibration remains constant. Look at the displacement time graph. When you draw displacement time graph, student, look at this graph. What I have shown over here. What is this vertical line is representing? Amplitude. Amplitude remain constant. Frequency remains constant. Now, what I told, one thing, what is natural vibration? Again, I am repeating. What is natural vibration? The periodic vibration of a body in the absence of any external force on it are called natural or free vibration. So, student, definition should be learned perfectly. There should be no change in the definition. Second, the factors on which natural vibration depends, shape and size. Third thing, where it execute, in vacuum. And the displacement time graph should be drawn properly. In the register also, it should be marked properly. What is the displacement time graph? What is this representing over here? Amplitude and frequency remains constant. And example you can take, if a bob of simple pendulum is displaced slightly from its mean position, it starts vibrating with its natural frequency in vacuum. Right? And frequency is given by the formula F is equal to 1 upon 2 pi square root of G upon L. G you all know. And L is the length of pendulum. Now, frequency of vibration in the stretched string depends on, these are the factors on which depends. Length of the string, how does it depend? F is inversely proportional to length. What do you mean by this? It means if I say, now see the factors directly it is not asked. It is asked application based question from here asked. Ki how can we increase the frequency of the stretched string? How can we increase frequency? By decreasing the length. How can we decrease the frequency? By increasing the length. How can we decrease the frequency? By increasing the length. So vice versa. The radius of the string, F is inversely proportional to R. Same way, tension, F is directly proportional to the square root of tension. Now from these three factors, you can ask many questions, many application based questions. Here, if I ask you, write how frequency of the stretched strings can be decreased. So what you can write? By decreasing tension, by increasing radius of the string, by increasing length of the string. Got it? Thus, the frequency of note can be increased by, see, frequency of the note can be increased by, on the basis of this factor. Increased, I said, frequency of the note can be increased by, how? Decreasing, because inversely decreasing the length of the string, by decreasing the radius, by increasing the tension. And you must read page number 156. Many more examples are given. You must read carefully and underline all the important points. Point 4, I would like to discuss. When an air column in fluid is made to vibrate, it vibrates with its natural frequency. But this frequency is how it depends on length of air column. Frequency depends on the length of air column inversely. Frequency is inversely proportional to the length of air column. In a fluid, the notes of different frequency are produced by changing the effective length of column when different holes in it are closed. Understood here? Like, see, one more example I am giving you. When we sit in a room and we come to know that bucket filled with water. How do you come to know? Bucket is kept under the tap and we are sitting in the room, but we come to know that yes, bucket is filled. How? Because when bucket is filled, water level increases and length of air column decreases. If the length of air column decreases, it means frequency keep changing. So we come to know that bucket is filled. I'll discuss later on. But you must read all the examples given on page number 156. Now I am going to discuss damped vibrations. Second type of vibration, damped vibration. Before going to discuss this damped vibration, again I am repeating what I said about natural frequency, natural vibrations, the periodic vibrations of the body in absence of any external force. In absence of any external force. Student, if you remember, earlier I told you, okay, if we set the bulb in the vibration, what will happen after some time? It will stop. Why it will stop? Because there is some external forces applied due to the presence of medium. So this is what we are going to discuss. Damped vibrations. Damped vibrations, the periodic vibrations of a body whose amplitude decreases with time in presence of resistive force is called damped vibration. Again I am repeating, the periodic vibration of a body whose amplitude decreases with time in presence of resistive force. See, here we look at the displacement time graph for this damped vibration. Amplitude is continuously decreasing with time, and after sometimes it's zero. Vibration stop. Damped vibrations, two forces act on it, restoring force and frictional force. Frictional force due to the surrounding medium. And natural vibration takes place due to restoring force only. So there is one force, only restoring force. But in damped vibration, two forces. One is restoring force and frictional force. The amplitude of motion decreases due to frictional force. But what we have discussed in free vibration, amplitude remain constant. The energy of the vibrating body continuously dissipates in doing works against the force of friction, and so amplitude decreases. After some time, it has lost all energy and it stops vibrating. So the rate at which the energy is lost to the surrounding depends on nature of surrounding medium and shape and size of the vibrating body. Now, the example will remain same as we discussed in the free vibration. When we say free vibration, example, a simple pendulum oscillating in vacuum. The same example in free vibration we will write here in vacuum, but damped vibration in air. The tuning fork, when struck on a rubber pad, execute the damped vibration in air, but when we say free vibration, we can say in vacuum. Now, here the difference between natural vibrations and damped vibration. Natural vibration and damped vibration, student. First definition, first point difference is definition. The amplitude of the natural vibrations remains constant and vibration continue forever. But damped vibration, amplitude of the damped vibration gradually decreases with time, and after sometimes the vibration is stopped. As there is no resistive force, so we can say there is no loss of energy. But in damped vibration, there is a loss of energy in the form of heat. Third, either you write definition or you write this third point. No external force act on it. But in the damped vibration, a frictional force or damping force act on the body. What the difference is? Understood? Fine. Once again I am repeating differences between natural and damped vibration. Very simple to learn. In natural vibration, student, what is constant? Amplitude is constant. And damped vibration, amplitude decreases with time. In natural vibration, there is no loss of energy. In damped vibration, there is a loss of energy. In natural vibration, no external forces act. And in damped vibration, external means resistive forces act on it. So we have discussed this free or natural vibration, damped vibration. Third, I am going to discuss forced vibrations. Forced vibrations, forced vibrations as word implement over here, there is need some external force. So the vibration of a body which take place under the influence of an external periodic force acting on it are called the force vibrations. For example, here you can see two pendulum A and B are there. There is a stand and the rubber string is there. This is 1 and 2. It is hang over here. If we just exert a periodic force over here, if you just exert a force on A, this is rubber string. So what will happen? This B will also start vibrating. But this B will stop after some time. It will continue only when you again set into the vibration. After the same interval of time, apply the force on it. So it will continue in vibrations. It means B is vibrating under the external periodic force which is acting on A. Understood this? For example, if we take a rubber band, or you just take simple example like a stem of a tree, right? A flower plant at home, you can see. If one leaf you just disturb, what happened? Other will also start shaking. But after some times, what happened? They all stop. Because now there is no external force. So this is what the force vibrations. The vibration of a body which takes place under the influence of an external periodic force acting on it are called force vibrations. Or you may define this way: vibrations produced in a body due to periodic force acting on it. The frequency of the force being different from the natural frequency of the body are called force vibrations. Yes, this is very important line. These two body, they don't have same frequency. Can you say why? You can see the length. Length is different. As we have learned, frequency is inversely proportional to the length. So length is not same. So frequency is different, right? The external applied force is called driving force. The force which is applied, that is known as driving force. The pendulum B that start oscillating due to driving force is called driven oscillator. This is driven oscillator, and driving force from where we are applying. The body execute force vibrations acted upon. Now there are three forces. Again I am repeating. We have discussed in natural vibration, which force acting on it? Restoring force. Damped vibration, two forces are acting. Which two forces? Restoring force, frictional force. Now in case of force vibrations, there are three forces acting on it. What are three? First is restoring, then second frictional force, and third is external periodic force. Periodic word means equal interval of time force is applied by external body. Now the amplitude of the force vibrations depends on the frequency of external force. The soundboard of all string musical instruments like guitar, violin and sitar execute force vibrations. We'll discuss later on all the examples. These are applications. One of them we are discussing here. In the string instruments provided with a hollow sound box containing air, strings are made to vibrate by plucking, which produce strings are made to vibrate, right? So which produces force vibration in air, in the sound box, because hollow sound box, so there are air molecules, so the air molecules are set into the vibrations. The surface area of air in the sound box is larger, so the forced vibrations of air send forth a greater energy and cause a loud sound, because large molecules of air are set into the vibration, so sound can be heard louder. Right? Now, difference between natural and forced vibrations. It is given in your book, and just you can write, read and learn. Just I am repeating what is there. First point is the vibration. If we talk about natural vibrations, the definition is the vibrations of a body, absence of any external force, but the force vibration, the vibrations of the body which takes place under the influence of an external force. Second point, you can say the frequency in natural vibration remains constant, but frequency in force vibrations changes with the change in frequency of applied force. The same way we can say amplitude. In natural vibration, amplitude remain constant. But in force vibration, the amplitude of the vibrations depends on the frequency of the applied force. Understood? You just read from the book and take notes. Learn and take notes. Now, next case, resonance. Now, student, we have discussed forced vibrations. Forced vibrations takes place under the influence of external periodic force. But one thing you remember, the body vibrates other than the natural frequency. Under the forced vibrations, when body vibrates, it does not vibrate with the natural frequency. Now, the resonance. Resonance is the special case of forced vibrations. There is slight difference. When the frequency of externally applied periodic force on a body is equal to its natural frequency. Now listen here, this line you please. When the frequency of externally applied periodic force on a body is equal to its natural frequency, the body readily begins to vibrate with an increased amplitude. So this vibration is known as resonance. This phenomena is known as resonance. The vibrations of large amplitude are called resonant vibrations or sympathetic vibrations. So what difference you got over here? The frequency of external applied force is equal to the natural frequency of the body. Understood? Definition? Please make it very clear. And words should not change when you write the definition. Now, condition for resonance. So, one condition from here only. The body, vibrating body, must produce sufficient external periodic force so as to set the other body into vibrations. The second point is from the definition only. The frequency of the applied force is exactly equal to the natural frequency of the vibrating body. So what is condition? The frequency of the applied force must be equal to the natural frequency of the vibrating body. Now here this demonstration with the help of diagram I would like to recapitulate all. And this is one of the questions. This demonstration is given in the exam also, and various questions is asked based on this diagram. See here, there are 4 pendulum. You can look at this and they are of different length. Now here, if you just look at, if I say this is A, this is B, this is C and this is D. There are 4 pendulum and different length, but A and B of same length. C, if I say L1, length of C is L1, but L1 is less than L. If I say D pendulum, length of D is L2 and but it is greater than L. If A is set into the vibrations, A is set into the vibrations, what will happen? What will be your observation? These all will start vibrating. They all will start vibrating. But what you can say, if it is asked, what can you say? What is observation about A and B? A and B will vibrate under resonant vibration. Why? Because length is same, and as we know, frequency is inversely proportional to the length of the string. So A and B have same frequency. Frequency matches. So B will vibrate under the resonant. It means large amplitude. But what about C and D? Their length are different. They will vibrate due to force vibrations. External forces applied, this will also start vibrating. But which kind of vibrations? Force vibrations. Understood? This is very important case. Now difference between force vibration and resonance vibration, student. Here first thing you can talk about frequency. First parameter is frequency. In force vibration, when a body oscillates with the help of external periodic force with a frequency different from natural frequency. Here the frequency will be not same, different from natural frequency. But in case of resonance, when a body oscillates with the help of external periodic force with a frequency equal to the natural frequency of the body. So this first point regarding frequency. Second point, you can talk about amplitude. In case of force vibration, amplitude is small. In case of resonance, the body vibrates with the larger amplitude. Then time duration, you can say. Force vibrations last for a short time, but resonance vibration last for a longer time. Then we can talk about phase. Force vibrations of the body are not in phase with external periodic force, but resonant vibrations body are in phase with the external periodic force. Now here I would like to suggest student, you must read the chapter and all the application based on the resonance you must read. You must read carefully application of the resonance vibrations. Example of the resonance vibrations. For example, at a particular speed in motorbike, their frame start vibrating violently. Why? Because due to external periodic force, natural frequency of the engine matches with the frequency of the frame. So it start vibrating due to the resonance. Resonance in case of bridge. When a troop crosses a suspension bridge, the soldiers are asked to break their steps. Why? This is again the case of resonance. The reason is that when soldiers march in steps, each soldier exerts a periodic force in the same phase, and therefore the bridge executes the force vibrations of the frequency equal to the frequency of their steps. So now if the frequency of the steps become equal to the natural frequency of the bridge will vibrate with a large amplitude due to resonance, and suspension of bridge may collapse. So please you read all the examples of cases of resonance and read the chapter thoroughly. We'll discuss the question answer later on. But first you read, and all the important point you must underline. After reading the chapter, you must read examples also. Once again, I am telling you. And definition should be learned thoroughly as it is given in the book. And whatever I am providing in the form of notes. You must take all the notes in your registers. God bless you. Take care.